Hello students, so we already discussed about crystalline solids and their properties. Okay, so you know what is space lattice, crystal lattice and different types of unit cells etc. we already discussed. So we can move through the crystal lattice. You know what is crystal lattice? Yes, it is a regular three-dimensional arrangement of points in space is called crystal lattice. That already we told, crystal lattice, and the more important terms also we discussed. What are the terms? That is lattice points, unit cells, coordination number etc. are the very important terms come under this crystal lattice. Okay. So while describing a crystal structure we need this type of important points. Okay. So in the last class we discussed and we calculated the number of particles per unit cell present in different types of unit cells, isn't it? Yes, I think you all remember those topics. Okay. So today I am going to discuss about different types of crystal systems and lattices. Okay. So we have 14 possible three-dimensional lattices are there. Okay. And that lattices are called Bravais lattice. What is called Bravais lattice? Because a scientist named Bravais discovered we have 14 possibilities for arranging this crystal system. Okay, so that is known as Bravais lattices. So how many Bravais lattices we have? 14 Bravais lattices. Okay, 7 crystal systems also there. So 7 primitive crystal system is there. We already discussed what is the difference between primitive and non-primitive crystal system. So you know primitive is the simplest form of the crystal system, isn't it? Yes. So primitive system we have 7 crystal system and the complex system other complex systems are also there. So for total we have 14 Bravais lattices. Okay. So now we move on to which are the 7 crystal system and the corresponding Bravais lattices. Okay, let me check. So we have 7 crystal system and 14 Bravais lattices. Which are the 7 crystal system? Okay, so you see, so the 7 crystal system simply we can represent like this. We can say like this, C-thrombed, because for easy remembering only. Okay, actually these crystal systems are, first one is cubic crystal system, second is tetragonal, third one is hexagonal, then rhombohedral, orthorhombic, monoclinic and triclinic. Okay, so you know we need 6 parameters for describing the crystal system, that also we already discussed. Which are they? 3 lengths and 3 angles, that is ABC length, that is the length along the crystallographic axis and the angle between them. These are the 6 parameters we need for describing the crystal system. So in the 7 crystal system we have different types of occurrence of these parameters. Which are the different types, how they occur in different crystal system? Let's look at this. So I told you we have 7 crystal system. We will remember in like this order, because this is the easy way of remembering. I will tell you the specialities of the lengths and angle, then you can realize. Okay. So in first one is cubic system, then we have tetragonal. Okay. So how will you write this? I told you. So listen here. Suppose you are writing this C-thrombs like this. When you write like this, you can remember like a letter E. You can like C-thrombed. C-T-H-R-O-M-E-T. Okay, I am telling a trick for remembering these 7 crystal system and their specialities. So for that trick, first you have to keep in mind, you have to thorough with the word, which is that word C-thrombed. Then you write the word like this, C-thrombed. Okay, then you will get an easy method for remembering the angles and the sides. Okay, so listen carefully. In C-thrombs you can see the first row. Okay, that is what? Cubic and rhombohedral. Okay, cubic and rhombohedral. What is this C-thrombed? That I'll tell you. First one is cubic, tetragonal, hexagonal. Then fourth one rhombohedral, or it is otherwise called trigonal. And fifth one is orthorhombic. And sixth one is monoclinic. Last is triclinic. This is what we wrote in a short form, C-thrombed. So first you have to write like this. Okay. Then you consider the first row. What is coming in first row? That is cubic and rhombohedral. In cubic and rhombohedral, you have this, all the sides are equal. That is A equal to B equal to C. Okay, so നമുക്ക് ഓർക്കാൻ സൗകര്യമാക്കി first row we have 3 sides are equal. A equal to B equal to C. 3 lengths are equal. Then what about the second row? That is tetragonal and hexagonal. Here A equal to B, but that is not equal to C. That is both in the case of tetragonal and hexagonal. Then what about this 3? Both 3 are unequal. A not equal to B not equal to C. So when you write like this, write like a letter E, you will get it like this. That is first row, 3 sides, 3 lengths equal, and in second row, 2 sides equal, but not, that is not equal to C. And in a third row, A not equal to B not equal to C. So this is the way. And what about the angle? Okay, this is the first column, isn't it? CTO. Here all the angles are alpha equal to beta is equal to gamma is equal to 90 degrees. So we can write like this. All the angles is equal to 90 degree. Then in second row, slight difference is there. You can write alpha in rhombohedral, alpha is equal to beta is equal to gamma not equal to 90 degree. Okay, that you have to remember. Then in hexagonal, what happened? Alpha equal to beta is equal to 90 degree and gamma is equal to 120 degree. Then what about monoclinic? Here alpha is equal to gamma is equal to 90 degree, but beta not equal to 90 degree. And in triclinic, alpha not equal to beta not equal to gamma not equal to 90 degree. So that is what I wrote here. Okay, so this is the 7 crystal system. Which are the 7 crystal system? So you see, first one is cubic. Here I told you the sides are both A equal to B equal to C. And what about the angle? Alpha equal to beta equal to gamma is equal to 90 degree. That also you can see here. Okay. And second one is tetragonal. Here I told you like this. Okay. So while you writing like this, you have to remember this system very easily. Suppose you know the structure of matchbox. Just you imagine the structure of matchbox and in which type of crystal system it is coming. We will find out. Okay, let's check out. So you know this is our matchbox, right? Okay, this is the structure of matchbox. The matchbox belong to which type of crystal system? We will check. Okay, so here you know the sides. When you look at the matchbox, the lengths, this length, this one and this one. 3 sides equal ആണ് matchbox ൽ no. A not equal to B not equal to C. Okay, so which category it will come? First row il varuo? No, because moonum equal ആണ്. In second row 2 are equal. So in third row there is a possibility, right? A not equal to B not equal to C. So third row we have 3 crystal system. Which are they? Orthorhombic, monoclinic and triclinic. So third row le edo oru structure aanu namukku manasilayi. Engane manasilayi? So in this structure A not equal to B not equal to C. So maybe it belongs to these 3. So next we check the angles. You know, angle is between this axis or this length. Okay, suppose this is A, this is B, this is C. So this angle between them is called alpha, beta, gamma. I told you last class. Okay, so you know in matchbox all the angles are right angles each other. So that is all the angles equal to 90 degree. So this is, you look at this, the first column CTO, which have alpha equal to beta equal to gamma equal to 90 degree. Early we find out which belongs to the third row, first column. So what is the structure of the matchbox? Yes, it is clear that this structure is orthorhombic. Orthorhombic. So that is why I told you this is very easy method for remembering the 7 crystal system. You got the idea? Okay. Okay. So that is the simple method for, or a trick for remembering this crystal system. Now we come to the system. So I told you we have 7 crystal system and 14 Bravais lattice. Okay. In cubic system, we already discussed in cubic system, we have 3 Bravais lattice. Which are they? We didn't mention the name there, Bravais lattice, but we already discussed the systems unit cell and we calculated the number of particles per unit cell also. Okay, I think you all remember. Okay, isn't it? Then come to this, we have 3 Bravais lattice. Which are they? That is simple cubic, then face centered and body centered. That all we discussed. Okay, that is the 3 Bravais lattice present in cubic system. Okay, so one example for cubic system is NaCl, zinc blende, copper. These are the examples for cubic system. So in the second system, tetragonal system, we have the Bravais lattices, 2 Bravais lattices. That is, the 2 are primitive and body centered cubic. Which are the primitive and body centered cubic. And the examples are white tin, SnO2, TiO2, CaSO4, etc. Okay, and then next third system, hexagonal. About the lengths and angles I told you. Then what about the Bravais lattice? Only one Bravais lattice is present in, possible in hexagonal, which is that primitive. One means that's only the chance for primitive only. About here only one, that means primitive. Example is graphite, ZnO, CDS, etc. Then fourth one is rhombohedral. It is otherwise known as trigonal. Okay, so rhombohedral system, sides and angles discussed. Then we have only one Bravais lattice, which is that I told you one means that will be primitive. Okay, so then example is calcite, cinnabar, that is HGS, etc. Then next fifth one, now we discussed the structure of matchbox, which is that orthorhombic. Orthorhombic system, this is the sides and angles. In orthorhombic system we have all the 4 types of unit cell. Which are they? That is primitive, face centered, body centered and end centered cubic. These are we discussed in this all the unit cell, or we discussed in our last class. Okay, do you remember? Then all 4 Bravais lattices are present there, that is primitive, body centered, face centered and end centered. So here example is rhombic sulfur, BaSO4, KNO3, etc. are the examples for this one. Then next is monoclinic. Monoclinic system, we have A not equal to B not equal to C here, and alpha gamma 90 degree, beta not equal to 90 degree. What about the Bravais lattice present here? Here 2 Bravais lattice. Which are they? Primitive and end centered. Which is the primitive and end centered. Okay. Then example is for monoclinic is monoclinic sulfur, Na2SO4, 10H2O. Okay, and the last one is triclinic system. Triclinic, and the sides A not equal to B not equal to C, and the angle alpha not equal to beta not equal to gamma not equal to 90 degree. Moonum equal allatha angle aayirikkum. Then here only one Bravais lattice present, which is that primitive. Then example is K2Cr2O7, copper sulphate 5H2, that is the pentahydrate copper sulphate, then boric acid. So these are the 7 crystal system with their Bravais lattices, and also some examples also you have to thorough. They will ask one word question like examples. Okay, so you should thorough with these examples also. And I told you we have 14 types of Bravais lattice. All the 14 types it come here. You just count this 3, 2, 5, 6, 7 plus 4, 11. 13, 14. So we have 14 Bravais lattice which is present in the 7 crystal system. So for easy remembrance of these 7 crystal system, I told you one method. What is that? You have to write like a citron, like a letter E, small letter E. You have to you have to write. Then you will get a easy method for remembering these parameters. Okay. So similar problem will work out one more problem. Okay, you simply look at the question. That is, in a solid, oxide ions, suppose O2 minus, are arranged in a CCP. CCP means the unit cell may be FCC. Unit cell is FCC. Okay, so cations A3 plus occupy 1/6 of the tetrahedral void. And one more cation is there, that is B3 plus, that is occupy 1/3 of the octahedral voids. What is the formula of the compound? That is the question. Suppose we know oxide ions are arranged in CCP manner. So FCC. So suppose let it be the O2 minus ion, let it be the number is N. We are taking number of O2 minus ion is equal to N. So in CCP structure, you all know, we already studied that in CCP structure we have 2n number of tetrahedral voids and n number of octahedral voids. If n is the total number of ions, then number of tetrahedral void is equal to 2n, and also the number of octahedral void is equal to n. Okay, so here the number of A3 plus ion, you know, A3 plus 1/6 of the tetrahedral void. So number of A3 plus is equal to 1/6 into how many number of tetrahedral voids we have? 2n. So 1/6 into 2n, that is equal to n/3 number. Yes. The next, the another cation B3 plus occupy 1/3 of the 1/3 of the octahedral void. Octahedral void equal to n. So 1/3 into n is equal, that's also n/3. So now we have to calculate the ratio. A3 plus cation is to B3 plus is to O2 minus anion also there. So n/3 is to n/3 is to n. Okay, that is simplifying, we will get 1 is to 1 is to 3. 1 is to 1 is to 3. That is what will be the formula? 1A, 1B, O3. So AbO3 is the formula of the compound. So this is a very simple question. They ask questions like this. You have to simply calculate the formula of the compound. It's a very easy one. You have to thorough with the number of particles and about the voids. Okay. So the formula here is AbO3. So next, one more problem you check. So here in this problem, cesium chloride has BCC arrangement and its unit cell edge length is 400 picometer. Calculate the intraionic distance in cesium chloride. So they already give that cesium chloride is in BCC structure. BCC structure means atoms or particles will be at the corners and body center. So look at here, all the corners and body center we have particles. They ask the question interionic distance, means the distance between the cations and anions. Okay, so here the cation, then as body center we have an anion. So interionic distance means the distance between the centers of the two ions, isn't it? So we already calculated the body diagonal of the body centered cubic unit cell. Okay, so that is body diagonal, we know that is equal to 4r, which is equal to root 3a. Yesterday, last class we calculated. Okay, so this is the body diagonal here. Here r plus 2r plus r, 4r here. But they ask the question, what is the interionic distance? So this is cation anion. So interionic distance may be how much? 2r. Okay, so the interionic distance may be 2r. So but we know the definition or equation for 4r. What is that? That is, we calculated 4r is equal to root 3a. Relation connecting edge length and radius, we already calculated the relation, that is body diagonal for BCC unit cell is equal to root 3 into edge length. So what about r? R is equal to root 3/4a, we know, but we have to calculate the interionic distance. That means how much? This r plus r, this is the interionic distance. So 2r is equal to root 3 by 2a. Root 3 by 2 into a, they are given, how much is a? 400 picometer. If they are given the answer in picometer, you have to calculate as such. If they are given the answer in centimeter or meter, you have to convert this picometer into centimeter or meter. You know, 1 picometer is 10 raised to minus 12 meter, and also 1 picometer is 10 raised to minus 10 centimeter. You have to do the unit conversion accordingly. Okay, here we need not do any conversion, the answer is in picometer itself. So, by calculating this, we will get 346.4 picometer. So, that is all about the problem. So, lots of number of problems do you have in your textbook, you all practice from your home. Okay. So, today we discussed about the 7 crystal system, bravest lattices, and the problems based on this. So, next class we will move on to calculation of the density of the crystal. How will you calculate the density? Okay. So, that we will see in next class. Okay. Thank you.